Okay, we talked last week about how to figure out what's going on at the ends of the graph. That's our end behaviors. We're going to go over that again. We talked about how to find the zeros, the x-intercepts. You just set it equal to 0, and 90% of the time you factor. So now we're going to talk about what it means, the amount of times or the number of times you get a 0. Okay, there's something called multiplicity. Multiplicity means more than one. So if you have an odd number of multiplicity, your graph is going to cross through the x-axis. And I'll explain what this means here in a second. An odd number of multiplicity, it crosses through the x-axis. An even number, it touches. They call it bounce or touch and turn. It touches but doesn't go through. What that means, guys, if you have f of x equals, say, x squared plus 4x plus 4. And I ask you guys to find the zeros for that one, and then x squared minus 3x minus 10, okay? In each example, f of x and g of x, how many answers should you have? 2, okay? So factor this. What are the factors of 4 that multiply to give me 4, but add to give me 4? 2. X plus 2x plus 2, right? So when you solve this, you get x equals negative 2. How many times? Twice, right? So you have the same answer how many times? Twice. So here you would have multiplicity. When you have the same answer 2 times or 3 times, you have what's called multiplicity. How many times do you have this one? 2. Is that an even number or an odd number? Even, okay? So over here, if you were to factor this, what times what's going to give me a negative 10 when I multiply, but a negative 3 when I add? Right? Negative 5 and plus 2. So you get x equals 5 and x equals negative 2. How many times do you have each of those? Once. So there's no multiplicity there. What it means in a graphing situation, right? Where does this first graph, f of x, where does it cross the x-axis? Right here at negative 2. But since you have negative 2 an even number of times, you have it twice, what the graph does is it comes to this point, and instead of going through, it bounces and goes the other direction. That's called bouncing or touching and turning. Over here, you have an intercept at 5 and negative 2. Is this a positive parabola or a negative one? Positive. So you know it's going to cross here, go down, and then come back through. Do you see the difference? Here, it just touches the x-axis and goes the other way. And here, it actually crosses through. So depending upon how many times you have an x value, that will tell you if the graph crosses through the x at the point or if it just bounces off the x-axis. So we're going to do 2 examples to show you guys the difference. Yeah?
When there's no multiplicity, it crosses like all the time.
Correct. You either have no multiplicity or if you have it an odd number of times, but very rarely do you have like the same answer 3 times. It'll either be usually just once or twice. So let's go over a couple examples and then we'll be done. All right, let's talk about end behaviors just to remind ourselves from last week. End behaviors. How do you find end behaviors? Where do we look? Highest exponent. Okay, what kind of a number is 4? It's even. So when I think even, I think of what? Same. The arrows are going in the same direction. That means they're both going what direction? Up, because it's positive. Right? So something like this. So tell me what my end behavior is from the left-hand side to the right-hand side. What's your end behavior? It's rising left. Whoops. Rising left and rising right. Good. And this is helpful for when we have to draw a picture of the graph. Yes, sir? You can write rising left and right if it happens the same way. All right, so let's talk about zeros. All right, 3x to the 4th minus 4x cubed equals 0. How many answers should I get here? I should get 4 answers. So let's go ahead. How do I solve this? What's the GCF? X to the 3rd, perfect. So then I have 3x minus 4. And then what do I do with each piece? I set them equal to 0. So x cubed equals 0. 3x minus 4 equals 0. So when you take the cube root, guys, what number times itself 3 times gives me 0? 0. How many times do you have x equals 0? 3 times, right? Is there multiplicity? Yeah. Your multiplicity would be 3 times. And then over here, I have x equals 4/3, correct? So it's going to look like the graph has only 2 answers, but it actually has 4. You know it has 4 because you have multiplicity of 3 times. So how would you graph that? Well, where does it cross the x-axis? At 0 and at, we'll say 4/3 over here. What'd you guys tell me the ends of the graph look like? They're both going what direction? Up, okay. And since your multiplicity is an odd number of times, 1, 3, 5, what's it going to do at those 2 points? Is it going to touch and turn, or is it going to go through? Go through. Perfect. Now, another thing to consider, how do you know how many bumps are in the graph? N minus 1, the highest exponent minus 1. So how many bumps are going to be in your graph? 3. 4 minus 1 is 3. So what this would look like, I don't know where it would occur. You'd have to have a graphing calculator, but it's going to come through and go back up, but it doesn't go through the graph. It's going to come back down and then go back up here. How many bumps does this have? 1, 2, 3. That bump in the middle is going to go back towards the x-axis, but it's not going to touch it. We're not going to get real crazy with the graphs, but just so you guys have like a mental picture of what that looks like. But if you were to have multiplicity, I have 2 examples. One will have multiplicity of even number, one will have odd. You'll see what the 2 graphs look like differently. Go ahead and change the second question to this. So on your quiz on Friday, you'll have number 1 might be like, hey, here's a point and the vertex. Write the equation in vertex form of the parabola. You'll have a question that says, here's a function. Tell me the domain, the range, the maximum, minimum, vertex, all that stuff. Then you'll have a question like this that says, here's an equation. How many turns does it have? What's the end behaviors? What are the zeros, multiplicity, and graph it? So let me show you how easy this is, guys. First of all, how many turns, how many bumps should be in my graph? N minus 1, so you'd have 2 bumps. 2 bumps, turns, however you want to call it. How do we figure out end behaviors? Okay, highest exponent is what kind of a number? It's odd, so I think opposite. Is it positive or negative? So the ends are going to resemble the end of a positive line. So reading from the left to the right, what's going on for our end behaviors? What's going on the left-hand side? Is it rising or falling? Falling on the left. And rising on the right, correct? Okay, perfect. How do you find the zeros? You set your equation equal to what? Okay. In this case, we're going to do that in group. If I have 4 terms, first 2 and the second 2. What's the GCF in that first group? X squared, perfect. And I'm left with x plus 1. What do I take out of negative 4x and negative 4? Negative 4, perfect. And I'm left with x plus 1. So x squared minus 4 and x plus 1. And then can I factor that a little bit more? Yep. What's x squared minus 4 become? X plus 2, x minus 2, and I have my x plus 1. So how many zeros do I have? 3. What are they? So x equals negative 2, negative 1, and 2. You can write it out however you want to. If you want to write x equals, x equals, x equals, whatever. Write them in order. But do you have multiplicity? Do you have anything more than 1 time? So your answer here would be no. And then what's happening at the x-axis? If you do not have multiplicity an even number of times, your graph goes through. If you have the same answer 2 times or 4 times, it's going to touch and turn. So what's it going to do here? It's going to go through. Perfect. That's exactly all you have to do to answer those. I don't need you guys to write me a dissertation or anything like that. You can even draw an arrow if you need to. I'll show you what I mean by that as we do more problems later in the week. So if we're going to graph this, guys, this is very, very simple, very basic. I'm not looking for anything super major. I need to see that the ends of your graph are doing the right thing. I need to see your intercepts, and I need to see that the graph does what it's supposed to at those intercepts. Meaning, where does this graph cross the x-axis? Okay, so I'm going to put a tick mark at -2, -1, and 2. See that? What are the end behaviors? Okay, so it's falling over here, and it's rising over there. And then what does it do at each one of those intercepts? Does it go through or does it bounce off? It goes through. So watch. This is literally all you have to do. We always start from the left-hand side. So it's going to go through -2, back to -1, back through 2. I don't care how high and low you go. That doesn't matter. But you just have to have the general shape of the graph. Your ends are doing what they're supposed to do. The graph went through at each point. And then how many turns did we say we should have? 2. Do I have 2 bumps? 2 turns? 1, 2. There you go. That's it. All right, let's do the last one, and then we're done. Watch the announcements. All right, if you didn't already change it, change this, please. How many turns should I have? 2. And -1, so 3 minus 1, 2 turns. Perfect. 2 bumps in your graph. Let's talk about end behaviors. What's the highest exponent you have? 3. So is odd or even? Odd. So what is the ends of the graphs going to do? Opposite or same? Opposite. And this is going to resemble what kind of an odd function? A negative one. So the ends of the graph will resemble a negative line. So tell me the end behaviors. What's happening on the left-hand side? What's happening on the right-hand side? It's rising. Perfect. Left. Good job, guys. And falling right. Now we're going to find our zeros. How do we find zeros? Okay, I'm going to do it out here. -2x cubed minus 12x squared minus 18. Put an x on there. I meant to put an x. Equals 0. GCF. -2x. Okay, so I'm left with x squared plus 6x plus 9. You guys agree? Okay, so now I have -2x. Can I factor? What is that? Plus 3 and plus 3. Okay. Now we set each piece equal to 0. So -2x equals 0. X plus 3 equals 0. X plus 3 equals 0. You guys can answer all of these questions exactly how I'm doing it right here on your quiz. You don't have to put it on the line and all that. You can do exactly what I'm doing. Watch. So we're going to find the x-intercept. So I have an x-intercept here at x equals 0. And I have one where? At -3 and at -3. So what do you notice? Do you have multiplicity? Yes, you literally can go like this, guys. And you could say, how many times do you have that? 2 times. You can tell me you have that one time. Don't worry about what the lines say on the quiz. Just draw me arrows. That's fine. So then what's going to happen at the x-axis here and what's going to happen there? At x equals 0, it's going through. And at x equals -3, it's what? Bouncing or touching and turning, however you want to say it. And what does that look like? Touch and turn. So you've just answered all of the questions. We already talked about end behavior, what it's doing. And then by finding the zeros, you identify the multiplicity and what it's doing. You could just draw arrows like that, like I did. You don't have to go back to the line and write it out. It's no big deal. So if we're going to graph this, where are my intercepts? At 0 and -3. If you want to put a million tick marks out, you can't. You don't have to. Just as long as the negative numbers are on the left of 0, the positive numbers are on the right, I'm fine with that. All right, so what did we say that the end behaviors were? Rising on the left-hand side and then doing what? Falling on the right, okay. This is where you guys got to pay attention. What is happening when I get to -3? Does it go through -3 or does it bounce and go the other direction? And then at 0, it does what? Goes through. So your graph would come down here, it hits 3 and then bounces the other way. I don't care how high up you go, it doesn't matter. But then you keep continuing your line, it's going to come through 0 and then go there. Do you see the difference at -3 and at 0? That's how you get the shape of your graph. If you have multiplicity an even number of times, 2 times, 4 times, 6 times, then it'll bounce like that at -3. But if it's just once or 3 times, it'll go through. Okay, that's it.